This is the second video in the process of recapitulation of the term relation. And now I'm going to start with the definition of relation. Actually, the first video ends with this particular term, but now I begin with this. So, first of all, definition of a relation is now. Suppose that we are having two sets A and B. Okay, we are having two sets A and B, and if we are collecting all possible ordered pairs which are made by taking first element from set A and the second element from set B, then that is called Cartesian product of A and B. And out of those all possible ordered pairs, suppose that we are taking sum and making a set, then the set is called a relation. As for example, if A is a set of elements 1, 2, 3 and B is a set of elements 4, 6. Okay, so A cross B is a collection of all possible ordered pairs which can be made by taking first element from set A and second element from set B. So clearly, as you know, there will be 3 to the 9, sorry, 3 to the 6. There would be 3 to the 6, that means 6 elements in A cross B. So there are all possible ordered pairs, 6 in numbers, and that would have been collected in this particular set. I'm just collecting 1 comma 4. I took first element from set A and second element from set B. Again, the first element from set A 1, second from B, that is 6. Similarly, 2 4 2 6, 6 is the second element and that is taken from B. 3 4 3 6. So clearly you are seeing that there are 6 elements contained in A cross B. That means A cross B, that is a collection of all possible ordered pairs that could have been made by taking elements from A and B such that the first element belongs to A and the second element belongs to B. Now suppose that some elements out of these 6 are taken away. Suppose that I took 1 comma 4 and 2 comma 4. Okay, and they are written under a set. So by taking these two, we made a set, and this set is clearly a subset of A cross B because these two elements are already in the set. So this set is a subset of A cross B, and according to the definition of relation, what is written here, according to this definition, this A cross B, this set, I am naming to this one as R. This set R is a subset of A cross B. Therefore, this R is called a relation from A to B. Is that clear? So this is a relation from A to B. So relation from A to B is nothing but a subset of A cross B. Mind it, this is a two-way traffic. If I say if I say R is subset of A cross B, then it means that R is a relation from A to B. And at the same times, if R is a relation from A to B, then it implies that R is a subset of A cross B. That means this is a necessary and sufficient condition for being a set relation. So why we write that R is a relation from A to B if and only if. This symbol is double implication and it means if and only if, or you can say that this is necessary and sufficient condition, necessary and sufficient condition, or you can say that it is written in such a way that its converse is also true. So R is a relation from A to B if and only if R is a subset of A cross B. Again, I am recalling to these two facts that if R is a subset of A cross B, then R is a relation from A to B. And if R is a relation from A to B, then R is a subset of A cross B. Okay, so this is now clear. You just recalled this one. Again, I am recalling something that is in fact some terms. These are some terms associated to relation. Terms are domain of relation, codomain of relation, and range of relation. First of all, what is domain, codomain, and range? To make it clear, I am taking an example, and with the help of that example, I would like to explain the definition of this. Suppose that A is a set of 1, 2, 3, and B is another set of 2, 4, 6. Suppose that I am taking a collection of some pairs. Mind it, A cross B is a collection of all possible pairs. Mind it, A cross B is a collection of all possible ordered pairs from A to B. That means the first element of A and the second element of B are taken together to make the pairs, and all those pairs are 9 in numbers. 3 3 are 9, so 9 in numbers, and out of those 9 I am writing here some 1 4 3 6. Okay, I wrote here two pairs under the head of R, set R. Then this R is clearly here. This R is clearly here. This R is clearly here a subset of A cross B. These two elements are contained in A cross B because the first element 1 is belonging to A and the second element is belonging to B. So this pair must be an element of A cross B. Having the same argument, 3, 6 is also an element of A cross B, and this set is a subset of A cross B. So according to the definition of a relation, this is a relation from A to B. So we write in this way: R is a relation from A to B. Okay, now we want to understand some terms associated to this. Just I said to you, that is domain of R. Domain of R. Domain of R is nothing but collection of all the first elements of those pairs which are in the relation, the set relation. Here, the relation, that is a set of ordered pairs. Mind it, whenever I will say or you will say that R is a relation, that means R is a set having some ordered pairs. Okay, so R must have ordered pairs as its elements. So out of these ordered pairs, if we think about the first elements of these pairs, so if we are taking the first elements of these pairs, then we are having 1 and 3. 1 is the first element of 1 4 and 3 is the first element of 3 6. So of these two ordered pairs, if we took the first elements 1 and 3 and collected them as a set, as elements of a set, then this set is called domain of the relation. Again, range of the relation. Range of the relation R. Range of the relation R. To this one you can also write in this way: range of R. I have written here R. So never be confused. So RR, that is symbol for range of R. So range of R is nothing but collection of all the second element. Look here, Y is the second element of the pair. So here we collected all the second elements of the pairs of the relation R. So if x comma y is belonging to R and we took the second element y and collected them, then the set is called range of the relation. Here these two pairs are having 4 and 6 as their second elements, and we collect these two uh, as elements of set. Then this collection, this set is called range of the relation. Okay, and now codomain. Codomain, what is the codomain of the relation? Codomain of the relation is nothing but the second set to which the relation R associates the elements of the first set A. I am repeating. R is a relation which is associating the elements of set A to the elements of set B. So the second one is set B. The second set B is called codomain of the relation. Is that clear? So here B is the codomain of the relation. Okay. Now a term that is very much in use in 12, that is relation in a set. If R is a relation from A to A, what does it mean? Suppose that A is a set of elements 1, 2, 3. Then if we want to collect all the pairs which could be made by taking first element from set A and the second element again from A, then we can make such kind of pairs. One with the 3 elements of A, the second element is also taken as A. So if this one is taken as the first set and this one is taken as the second set, then the one is belonging to the first set, first element, and one to the second set, A. So 1 1, 1 2, 1 3. Similarly 2 1, 2 2, 2 3, 3 1, 3 2, 3 3. So these are all possible ordered pairs which are under A cross A. Suppose that any set is made by taking sum of the elements of these. Suppose that I took 1 1 and 2 3. Okay, so this is clearly a subset. This is clearly a subset of A cross A. Then this R is called relation in A, or sometimes we say to this one on A. So never bother about this preposition in or on. Actually there is no difference between these two. Here we mean that we are talking about a relation from A to A. Okay, now I am taking an example to make clear inverse of any relation in the second phase. First of all, understand what inverse of any relation means. Actually, inverse of any relation means nothing but the collection of those ordered pairs which are contained in R in reverse order. If A comma B belongs to R, then B comma A belongs to R inverse. So if R is having elements like this, then R inverse, that is inverse of this relation, will contain these two elements in reversed order. That means the pair 2 1 would be written as 1 2 and the pair 4 6 will be written as 6 2. Is it clear? So this one is called inverse relation of the first one, relation R. Okay, and now this is the very simple mentioning. Actually, domain of R is range of R inverse. Clearly, the first element of the set first element of relation R 2 and 4 are now the second elements of R inverse. So clearly, domain of R is now became the range of R inverse. So the range of R inverse is equal to the domain of R, because the first element of R is now the second element of R inverse. Similarly, the second element of R is the first element of R inverse. So these elements are written in reverse order, and due to that one, domain of R becomes range of R inverse, and range of R becomes domain of R. Okay, I just said that I am going to take an example to make it clear, and this is the last topic of this video. This is a very simple example. Actually, this example is only taken to this example is only taken to okay. Okay, I take another example that will be very simple one. Okay, suppose that R is a relation from set A to B, where set A is equal to a collection of 1, 2, 3, 4, and set B is a collection of 2, 3, 4, 5, 6, 7, 8, 9, 10. And this R is defined as a collection of the pairs A comma B, where A belongs to A and B belongs to B. Okay, so this relation is from A to B, where the pair A comma B is such that the first element A is of set A and the second one is of set B, and they are having a relation that A A divides B. Okay, having this one, we are to write these things. Number one, write number one R, number two R inverse, number three domain of R. You can write to this one as also. Again, fourth one, domain of R inverse. Okay, so these are to be formed, and this is very simple question, and this is the last example in the process of recalling the relation. Here, first of all, I would like to write down the relation R. Okay, so in the process R is equal to what will be, its member will be taken in such a way that the first element A divides the second element and the first element is of the first set. So clearly you know that this one divides to all these elements, so it will be paired with all of them. So 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6, 1 comma 7, 1 comma 8, 1 comma 9, 1 comma 10. Okay, and the second element 2 will be dividing to 2, 4, 6, 8 and 10. So it will be collected with 2, 2, 2, 4, 2, 6, 2, 8, 2, 10. Okay, now about 3. 3 divides to 3 of the second set and 6 and 9. So 3, 6, 3, 9. Similarly, this 4 is now dividing only to these two elements 4 and 8. So it will be collected with 4, 4 and 4, 8. So these are the elements of the set R. So now think about the domain. Think about the domain of this set. Okay, domain of this set. Domain of R. What will be the domain of R? Clearly, the collection of first elements of these. Collection of first elements of these, that is 1, 1, 1, 1, 2, 2, 2, 2, 3, 3 and 4. So domain of R 1, 2, 3 and 4. Set of 1, 2, 3 and 4. And again you just think about domain of R inverse. What will be? What will be? Actually R inverse is written in the reverse order of these pairs. So the second element will now become the first element of R inverse. So why the second elements are only to be taken as the elements of domain. So the second elements 2, 3, 4, 5, 6, 7, 8, 9, 10 and all of them. So the 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, these are taken as domain of R inverse. Okay, is this clear? And now this is the end of this recapitulation video. Thank you. Have a nice day.